Thank you very much. It's interesting hearing the story of Southwest told that way, and amazing at what can happen in just 30 years. The way our society works, though, typically we want it in just a couple of years. Oftentimes the examples are a few decades, but some of the really amazing things, can take even centuries. I'm looking back now a century ago and thinking about what it would have meant if I wanted to just grab a glass of tap water. This would basically be a choice I was making between whether I wanted to risk my life or quench my thirst. And it's an interesting challenge to think about it, because when we talk about innovation, I think that the gauntlet that's been set is actually right. You need to think about something that's going to have a transformative change. And you think about clean water, I think that most people will cite that as an example of one of the great healthcare innovations of the past century, which is impact on infant mortality. So you go back to 1900 and look at the mortality curves over the following century, and you see the risk of infant death drops in an astounding fashion. And almost everybody thinks that's because of clean water. It may be partly because of clean water, but how many of you folks know when chlorination started in the US system, Western society? Anybody have a guess? 1930s. I guess chlorinated water can't be the reason. These are interesting questions because I think what it does is it allows us to take a look back and understand that many of the things that we look at as the big innovations are directed at one goal and yet have one elsewhere. I think if you look at all the data that exists, you'll probably find that the innovation that may be the most responsible for drop in infant mortality could be the automobile. It was the introduction of the automobile that took horse manure off the streets of our urban centers and enabled a sanitary inner city and urban center to start around 1900. Now you may say, well, what's the relevance of that? Well, I bring up manure because it is certainly a topic that everybody in New York loves to discuss, of course, historically speaking, because in 1890 or so, a conference was called with the world's greatest civil engineers and the equivalent of civil engineers, mostly focused on the problems that were being faced in London and New York, where they estimated by about the year 1950, horse manure would reach the level of a third-floor apartment in New York City, in Manhattan, or in downtown London. So they realized this is a big problem. Now, if you just take a step back to 1900 or so, realize that everything that was going on in the cities was about horses transporting it. In fact, that may have been the beginning of our obesity crisis, because that's when the omnibus started to become the way people got around inner cities. Instead of walking, they were drawn in these horse-drawn vehicles. And the extent of the manure was so great that basically, there were basically bugs and there were diseases. The rain would come, it would run off into the sewers, which fed into the water supply. That's why the water was such a problem in the urban settings. In New York City, in the year 1900, horses produced 2.5 million pounds of manure a day. You can start doing your kilogram conversion. It's a lot of manure. And what people then did in that conference was they said, let's get together for 10 days and let's design a policy, design regulations, design rules that will enable us to get rid of the manure problem, because the manure problem is horrible. So they had this 10-day conference, the world's leaders, they got together, they were going to establish the policy, they were going to establish the rules that would solve the problem, a neo-government type approach. Well, after the 6th day, they canceled the rest of the conference, coming to the conclusion that they couldn't figure out an answer, and hopefully somebody else figures it out, that's it. Very illustrative. You can't regulate a solution. Instead, what you need to do is create an environment that allows the solutions to bubble up and then be smart enough to appreciate those solutions when they present. What I'd like to do is talk a little bit about the kinds of changes that I think are necessary to establish that kind of environment. and then put forward what I would propose as at least one person's policy recommendation. The first thing that we would need to change is decision making. Think about any of your companies. You have some sort of safety group, you have your risk managers, you have the people who are going into the regulations. How am I going to mitigate the risk of this or that? It's all about risk. Now let me ask you a question. When you go to make your investments, do you only look at the likelihood of your equity dropping? Or do you also look at the potential reward? Humans make decisions every day on a risk-reward basis. And yet, regulators, especially in the healthcare field, but I believe across all regulatory agencies in the US, you can make this case, probably in other countries as well, instead of taking this two-sided, balanced approach, which therefore would include the risk of not getting a treatment or not getting a diagnostic to the patients in need quickly, take that into account as well, and also the upside of even marginal chance of benefit with that disruptive innovation that then grows into a high impact, either doing the equivalent of wiping out infant mortality or making everybody feel better or allowing for procedures to be done that affect public health. If we were to shift to that risk-reward, I think we would see a very different approach. And that's exemplified by chlorinated water. Chlorine in World War I was a chemical weapon responsible for tens of thousands of deaths. And yet these two academics in New Jersey got together and said, you know, we could probably kill all that stuff in the water with chlorine too. I wonder if there's a way to really control it precisely enough so that we could use this chemical weapon about which only risk had been discussed and look at the potential reward and repurpose it and turn the equation on its side. It worked. And starting in the 1930s, we started to get clean water that really made a huge difference in public health. And there are lots of other examples. If I mention arsenic, probably you'd think, well, the great poison to be used in a spy thriller. Some of you in hardware might say, well, it's real important when we dope our silicon wafers. And yet, arsenic actually is toxic when used at a very low level to a specific kind of leukemia cell. So some scientists realized that they could take arsenic in a particular form, control its dosage and its availability biologically very carefully, and all of a sudden, patients with promyelocytic leukemia can be saved by getting arsenic, by being administered arsenic. Truly amazing when you start to take those risks from one field and flip them on their side and figure out where you can repurpose them or reapply them. And part of what's necessary to be able to do that, I think, is a little bit of a mindset shift on all our part, whether it be the public, the patient, the regulator, all have to think differently. And what's the best way to do that? You lock patients in the room with the regulator. You lock patients in the room with the doctor. You lock patients in the room with all the people who are involved in the development, the decision-making, and the utilization of technologies, of drugs, of these kinds of breakthroughs, even of processes. And I'll tell you, when I was at the FDA, one of the things that I saw as a really critical opportunity, and I really hope that this opportunity will be realized in the coming years, is the effort to develop an artificial pancreas for the treatment of diabetes. Part of the reason that I found that to be such a compelling project was because I have a friend whose daughter has diabetes. And if I go back 8, 10 years ago by now, I remember going to visit my friends. They lived in North Carolina. I was coming down, spending the weekend. I got there late one night. We were sitting around having a little wine. It was 11 o'clock at night. And all of a sudden, out of this really just wonderful time, we hadn't seen each other for a while, we're having a really terrific evening. A 7-year-old girl walks out half asleep, about 11 o'clock at night. And you can barely hear her speak. And she says, "Mommy, I think I'm low." They jumped up, quickly did a finger stick, administered orange juice. Indeed, she had a blood sugar of about 30. What's remarkable to me about that is that this little girl had a chance she actually felt it. So she woke up. She didn't have a stroke while she was sleeping. She didn't die suddenly while she was sleeping, just because she was able to sense it. She was lucky. And this was not an isolated occurrence, and if you talk to people who have diabetic children, it is not an unusual thing to happen. And yet, as regulators and as product developers and as investigators, I see over and over again the goal for the perfect device, to replace the anesthesiologist, instead of saying, how can we make sure that Cassie wakes up every morning? I mean, that's a pretty remarkable thing to witness, and I think the more we spend time actually looking at the patients, sitting down with the patients, listening to the patients, and getting two peers to do the same thing, the more likely we are to start changing that mindset, and I think that's real important. But what's also possible are some practical things, some easier things. For example, when I think about an artificial pancreas being stumped, I'm starting to talk to people who are engineers, hardware, software, pharmacologists who have diabetes or have diabetic kids. And I say to them, look, you can go through this process, and it'll take you a while. You've got something that's really great and disruptive. You know that you, as a user, if your doctor tells you that you need a custom device, you can make one for yourself under doctor supervision and not have to worry about what the repercussions are, unless, of course, you're not a very good engineer, or you write bad code, or you don't know how to formulate a drug. But there are some amazingly talented diabetics. Maybe that's a way to start disruptive innovation and change that user experience. Another what if. A big area of need in healthcare is giving people access to information, giving people access to guides to tell them how to manage their health, and even in potentially some point manage their disease. So you can think about this as the mobile apps, wireless apps, software, decision support arena. And the FDA is working very nicely, I think, to start carving out some areas where they're telling people, in this spot, we're going to use enforcement discretion. Go ahead, develop as much as you want. And I say that because software used to diagnose or treat a disease is a medical device by statute. So the FDA said, okay, these are low risk enough, go ahead. I think it would be interesting if you started again to shift from that risk view to a risk-benefit view, to start saying access to information with appropriate controls, with a good user interface, with some central oversight, with a quality control, with a robust platform that doesn't crash all the time. Oh, wait a minute, I think I have one of those. So what if, I'm holding an iPad, sorry, I'm not a shareholder in Apple or anything like that. What if the Apple App Store were the place that basically were a de facto standard set of procedures you needed to follow to market a mobile app? If you were to look at the software development kit and the requirements, it's actually a pretty robust set of steps you have to go through to write an app. That's the kind of opportunity that maybe Apple or some organization that wants to put a system like that in place could start out with and challenge the regulators and push the regulators, saying this is an important way to expand access, which is a key part of the reward side of the risk reward. And I was very interested when you spoke about Six Sigma, because we have had a mantra at the FDA, which was that there's Six Sigma and anti-Six Sigma. If you're talking about an organization and you want to spur innovation and improve the quality of performance, those are two independent functions. Interdependent, I probably should say. So you use Six Sigma to get all the variability out of the system where you want it out of the system. But the way I've seen Six Sigma applied, it's applied to everything, which means anybody with a good idea has no chance to let that good idea bubble up. So that's why I like the anti-Six Sigma, and you might like my acronym there. That's a very important part of how you figure out a way to design a system that encourages the innovations to come forward. We had them at the FDA. We were starting a mechanism whereby we would have the reviewers who came up with innovative approaches to share those across the Center for Devices, so that we could get people to start sharing their innovations, to start populating the ones that made sense, for which there was some success, and then give them some support. And I think that's a useful approach. But in the setting of all of these kinds of changes, well, none of them are going to work, really, without one critical ingredient. And the one critical ingredient would be my recommendation for a policy change that would be stronger than a regulation, that in and of itself creates incentives, and that's leadership. We actually need more leaders who actually want to lead as opposed to manage. So we've done things within the FDA where we launched an innovation initiative, and it was amazing to me to see how actively the stakeholders who engage with the FDA regularly were willing to shoot them down, diminish them, undermine them, not contribute to them, talk in public about why none of them were good ideas, and put forward no good ideas. What we have is we have an organizational awareness and approach where when we say we want to start a test bed to try out some new ideas, test them, and if they look good, and we'll invite you in and you can be part of it. That's part of what the entrepreneurs in residence at the FDA is doing right now. You can be part of it if it works and we can show you metrics or some case studies. Then we can start expanding it across the center and testing it and improving and making the environment a better one. Making the environment not one where there's no regulations, I do not believe in that, but where the regulations and the application of those regulations become permissive for the innovators, become permissive for the patients in need, so that progress in a substantial way, in a potentially transformative way, makes it forward. So there are examples in the US government where these kinds of steps are taken to change the landscape, to bring it about. One that I'm very focused on, it's where my company is focused, is the area of repurposing the advances in regenerative medicine to other purposes. So there are hundreds of millions, if not billions of dollars that have been invested in growing organs to be implanted for the treatment of chronic disease, whether that be a kidney instead of a transplant from a living or a dead donor, growing one from your own cells, or a liver or a heart. I mean, these are really pretty amazing things, even a pancreas for diabetes. But instead of continuing down that route alone with those technologies, where the barrier now is figuring out how to implant some of those organs that actually can be grown in a lab already, and shifting that so that these organs, which are grown from human cells, could be used to test drugs. And we think that's kind of novel because right now, if you look at the way the pharma industry works, 1 out of 9 drugs getting to market, getting into clinical trials makes it to market. 11% success rate. And that's after 250 went through animal tests. And the reason, in large part, animal tests don't predict what's going to happen in people. So if you want to know what's going to happen in people, why not start with testing those drugs on people's organs? And that's what we're doing. Again, the idea of repurposing to figure out a new way to approach a model. And we'll see how much disruption we can create with that. And the reason that comes to light in the field is because there are 2 agencies within the federal government, US federal government, that are basically sticking their neck out and saying, we believe that our standard investment in regenerative medicine that's extensive in the billions of dollars is great, but we actually see a way that it actually can be worked into a commercial and high-impact product in the short term. Not abandoning that old investment, but the Department of Defense, which is very focused on regenerative medicine, especially to treat returning soldiers, the National Institutes of Health, have both dedicated in the tens of millions of dollars over the next couple of years for this project. So there they are, sticking their neck out by pivoting, by starting to say, okay, this path is good, but there's also another opportunity over here. We're going to take it. We're not going to be a ship that can't readjust. And we're going to readjust, and we're going to take that gamble. So when I think about how to institute my recommendation of leadership, as you probably all are, it's not so easy to figure out how you're going to identify the leaders to take this kind of task on. You can't regulate, you can't legislate innovation, you can't regulate, you can't legislate leadership. I think that what we can do in this room is we can look towards some examples that may be helpful to us in being leaders in our own little spheres. And while I don't think any of us necessarily should try to uphold the standards of a Richard Feynman, a Nobel Prize winner, I think it's interesting what he did. So here was Richard Feynman, one of the great physicists of the last century in the world, certainly in America, certainly in Northern America. And what he did after his significant contribution in the Manhattan Project, which was probably notable for his physics, as much of his disruptive humor and troublemaking in that period, was that he was giving a lecture at Caltech in 1959 when he decided that he was going to put forth a challenge, that that's what it took. And this is similar to the way X Prize and other foundations are now creating these prize challenges. It was a little different. Instead of a $10 million prize to get into space, like the X Prize did, he offered $1,000. There was a lecture that was called There's Plenty of Room at the Bottom. And he spoke about the day when a physician could be swallowed. A lot of examples like that, many taken from the science fiction literature. And his challenge was he would pay $1,000 to anybody who could build a working electric motor that had no dimension greater than 1/64 of an inch. It took about 2 years before he paid up that $1,000. And then he took, his second one was he said he'd pay $1,000 to anybody who could take the Encyclopedia Britannica and shrink it down so it fit on the head of a pin. I'm looking around. Most of us remember what the Encyclopedia Britannica is, right? Okay, I once told this story to one of my daughters, and she said, what's the Encyclopedia Britannica, Dad? And that one took 20 years, 23 years before someone could do it, and then Feynman paid it off. Now, what's remarkable about that is if you had a Nobel Prize winner standing up in front of a room, giving you a lecture, and making that challenge, that's a pretty strong incentive. It's as if you've got a leader who you want to please, a little bit of money, but it's really the fact that you can fulfill a challenge that a Richard Feynman can't do. And what we need to do is look for those opportunities when we can set forth those challenges in our little spheres of influence. And perhaps one other way to think about the leadership is to go back to the idea of the Manhattan Project, led by Robert Oppenheimer. Dr. Oppenheimer was a brilliant physicist, but probably the stupidest member of the team. What Oppenheimer did was he realized that what was really necessary was to create the team of all-stars. I don't know if this is the inspiration for Jim Collins's books about how to make great organizations, but if you go back, this one, the Abraham Lincoln model of how he created his cabinet, it's about getting the best people around you, people who are smarter than you, better than you, more talented than you. What Oppenheimer did was he kept the military at bay, he broke down barriers, he created the permissive environment. There's no stronger regulated environment you can imagine than the US government developing the nuclear, the atomic bomb in secrecy in Los Alamos. And yet within that incredibly regulated and appropriately regulated environment, Oppenheimer was able to create the kind of environment that was permissive to those with talent to achieve great scientific levels, regardless of what you think about the atomic bomb. So my proposed policy is not a new regulation. It's not a new incentive. It's to look for the leaders amongst us, be leaders to each other and to our peers. Thank you.